very much for that introduction. I'm going to try to adjust this so it works. There we go. So I'm Ben Holmes. I am the founder and CEO of NANOCHON. We're an early-stage medical device company, which is developing an implant to treat probably the biggest problem in orthopedics today, and that is osteoarthritis. So I am willing to bet that everyone in this room has some familiarity with osteoarthritis, whether it's personally or a friend or loved one. As I assume we all know, this is a degenerative disease of the joints where the cartilage itself that makes up the surface of the joint starts to break down and wear away. And over time, as that degeneration progresses, eventually in large joints like the knee, an actual lesion forms. The best way to think about it is it's like a pothole in the road. So this large coin-sized hole has formed in the cartilage, and that's a challenge because at that point the disease is very painful, very symptomatic, and this is also the point at which people seek treatment. Unfortunately, nothing can really be done except for a number of painful and inadequate treatments to try to delay the inevitable need for a knee replacement. And so that's exactly where NANOCHON wants to intercept patients and intercept people living with osteoarthritis. You're at the point where it's very painful. You go to the doctor, they say, I'm sorry, there's only a few things we can do. We want to change that paradigm. So our implant is a fully synthetic device. It's designed to actually mimic the properties of cartilage, but also encourage the body's own cell populations to grow in and regenerate tissue. And so we achieve that through a synthetic material. It's a polymer-based nanomaterial that actually replicates the structure of collagen. And then we 3D print it into a structure like you see here in the graphic. And I have some samples of the device actually on my table if you're interested in seeing afterward. But they basically create a device which, as I said, replaces the cartilage properties and then allows the body to heal itself. And that's really important because today, the options that patients have that want to either delay or put off that knee replacement and are hoping to not need a knee replacement later in life don't actually achieve that goal. The first option is something called microfracture. All you need to know is it's a purely surgical technique that's easy to do, but there's actually recently published clinical evidence that it actually accelerates the progression of osteoarthritis. So surgeons are very rapidly trying to get away from doing this treatment. What patients are left with are cadaveric allograft, which is a transplant of cartilage and bone, very expensive and hard to implement, and then also cell therapies that are also highly expensive and don't have better outcomes. And so we want to offer something that has much better outcomes, but also can actually be cheap and easy and off the shelf. We've done a lot of research to date in multiple animal models. Most recently, we did a study in horses. And what you need to know here is on the left, that's how people are being treated today. If you were to go into the doctor's office with this treatment, this is what your knee would look like a year later. On the right, that's NANOCHON. What's really significant is we showed that you not only get a high-quality cartilage, but our implant also addresses the bone degeneration as well, which is why this condition eventually leads to needing a knee replacement. So we now are confident we have a solution to really offer long-term care. This is a very healthy and growing market, about $2 billion annually in the U.S. We also think there's great opportunity to expand into other joints beyond the knee, and then also use this for a variety of soft tissue reconstruction. I myself, as I said, CEO, have been leading the company for a number of years now, have raised actually a little over $7 million to date. About $1 million of that is from grants. My co-founder, Dr. Castro, is also a very experienced researcher in cartilage, biomaterials, and regeneration. And we also have a very strong core team that's helping us develop and commercialize this technology into a successful product. And so finally, to summarize, we do have an open round, although we're closing in a couple weeks. Our original target was 3, and we're actually oversubscribed up to close to 4 now, but there is plenty of room left. So if anybody wants to get in, now would be the good time. This funding is going to go to a first-in-human trial down at LSU to start later this summer. And then eventually we're looking at FDA approval and potentially an exit sometime in late 2027. So again, I'm Ben Holmes. We're NANOCHON. Thank you very much.